Welcome to the lair of the Batty Boffin.
Hi Batty fans, it's time for a little bit of GCSE exam practice with the Batty Boffin, helped as always by Bathilda. Now, Bathilda today has been making sweets and she's decided to make a refreshing loop-shaped mint sweet, which she's decided to call Ollop. I'm not sure where she got that name from. She's making a giant one as a prototype, and she started off by making a cylinder that is 15 centimetres in diameter and 5 centimetres from top to bottom. Then, in order to make this refreshing hole in the middle, she scooped out the middle and had to eat it, and she found when she did that, that the amount of sweet went down by 25%. Okay, so when she took away the hole out of the middle, she took away 25% of what she'd had before. So for part A, please, could you calculate, please, the radius of the hole in the middle? Okay, off you go. Right, well, there are a couple of ways you can do this. The first one is to look at the volume of the original sweet and the volume of the hole and then take the two away. I've called big R as the radius of the whole cylinder, and then little r the radius of the hole that's missing in the middle. So if we look at the volumes of those, the volume of the whole cylinder is pi times big R squared times the height, which is 5. Okay? The hole in the middle is pi times little r squared times 5. And we're told that the hole in the middle was 25% of the whole square, the whole cylinder originally, which means if you take the original cylinder and divide it by 4, you'll get the volume of the hole in the middle. Okay, so using all that lot there, and we can substitute in for R because we know what that is, we can find out the value of little r. Big R was 7.5, please, not 15, so that's a 7.5. Right, we can do some rearranging, plenty of cancelling here. At which point we grab our calculators and we switch it on. That always helps, I find. And we go 7.5 squared is that, divided by 4 is that, and then square root the answer. We get 15 over 4, which you can leave as a fraction or as a decimal. R equals 3 3/4, and that's centimetres. Okay, that's one way of doing it. The other way of doing it is with similar figures. Now, you probably noticed that the 5, the depth of it there, cancels. Well, that's quite right, because actually we only need to look at the flat face. Now, if I just rub this out, I'm going to do one of those speedy up bits. Okay, now we know that the area of the big circle is pi big R squared. We know that the area of the little circle is pi little r squared. And we know that the factor between those is 4. Okay, the little one is a quarter of the big one. Okay, so to go from the little one to the big one, we do a times by 4. That is the area factor. It's like scale factor. Scale factor is how many times you make a length bigger. This is an area factor. So we've got an area factor of 4. Hopefully you know how scale factors and area factors are linked. The area factor is always the square of the scale factor. So that means if the area factor is 4, that means it must be a scale factor of 2. Scale factor of 2 means that all lengths are doubled. So if the big one is 7.5, the little one is linked by a scale factor of 2, i.e. it's half of it. 3 3/4 or 3.75. Either of those methods is fine. Right, I'm now going to wipe down the board and we're going to come back with part B. Prepare for that kind of black thing. Right, welcome back. Here's part B. Now, Bathilda has got her Ollop here, and she's decided to put it on the stand to display it in its finery and glory. She has made a little stand by taking a 5 by 5 block of wood and just scooping a bit out the top so that it sits on it very nicely. Okay? I'd like to know what the area is, please, of this front face of the stand. So the area of the purple shaded bit. This is quite a complex one here, so don't worry if it takes you a while to do it. This would kind of be like a 6-mark section. Anyway, have you go. Find the area of the purple shaded bit. Right, in order to help us calculate this, I've added a few lines to the diagram. We've got a couple of radii there and a little chord along the bottom making an isosceles triangle, which I'm going to draw out a bit bigger now. Right, so we've got an isosceles triangle and then that curvy bit at the bottom, and the two together make a segment, that kind of dairy cheese shape. Other brands of spreadable cheese are available. We need to know the area of that kind of narrow D shape at the bottom, because then we can take it off the 25, which is 5 by 5, and get our answer. In order to know that little fat bit there, we need to know the whole sector, take away the triangle. Okay? In order to do the sector, we are going to need the angle at the top, which I'm going to call theta. Okay? And we can find theta by trig. If I split this isosceles triangle in half, we're going to get a nice right angled triangle. Now, hoping that you're okay with this this is fairly simple trig, I'm going to do this bit speeded up. Okay, so that gives me an angle of just over 19 there. Of course, I don't want that bit, I want to double it for mine at the top. Don't forget to do that, so times by 2 equals. Gives me an angle up here of 38.94 degrees. Right, using that we can now calculate some bits, the area of the sector. So I'm just going to wipe this down, then we'll do that. Right, by the way, if you didn't get that trig bit, watch some of the other Batty Boffin videos where I'll go over that a lot more slowly, but I was just getting through because there's a lot to do in this question. Right, to calculate the area of the dairy cheese shape, we are going to do our angle, 38.94, out of 360, because that's what fraction of the circle we've got, times the area of the whole circle, which is pi times the radius 7.5 squared. Okay, so this is going to give us the area of the sector. Then we're going to do the area of the triangle. That'll give us the area of that little D shape, and finally we'll get the area of the stand. So, having got my angle, so that's 19.11, actually it's 116, isn't it? Okay. So that's a 1 for there. Now we need the area of the triangle. Now 2 ways you can do that. You can either do it by calculating the height of this dotty line using trig again, or you can use that other triangle formula, the area of a triangle being half base times height, or half AB sine C, which is actually just finding the height of that using trig and then doing the same thing. Again, I'm going to nip through this quite quickly. Other things have got areas of a triangle in it. So half AB sine C. We get an area of, hopefully you have got, 17.677. Okay. Subtract from that the number you first thought of, 1.439. Subtract that from the 25, that's the 5 by 5, and we get, ta-da, 23 point, rounding to what, I've done this to 3dp here by the way, just so I don't get rounding errors, 23 point, that will be 6 by the time we round it to 1dp. Right, 23.6 for that. I hope you got that. Quite a lot of calculations in there. If there's any of these steps you're not sure of, then check out other Batty Boffin videos where we do things like area of a sector, and I'll just do a whole video on area of a sector or area of a triangle using this formula. So all those bits are done very slowly in other videos. I hope you had fun with that, and I'll see you for another one later on. Bye for now.